Everyone. Today I thought of doing a very daring look into, very mean, very evil, two ways to describe it. This integral right here, the integral from 0 to infinity of e power minus t squared cos of 2x t dt. And it's got like a 2x as well. So first of all, it's respect to t, which you're probably not used to. Usually it's like usually dx. But then there's an x involved. And you think, how do you even do that? Like it don't make sense. But fortunately, there are some methods we could use that might be able to destroy the integral, even though it has too much aura at first when looking at it. So yeah, today I'm going to be showing you how to defeat it and some really cool tricks you can use. So there's two tricks you can use for this. Probably Feynman's trick, or using summations and a whole bunch of stuff, um, and gamma function. But like I'll say up for another video for like another time in school. I'll teach that. So yeah, I'm gonna focus on Feynman's trick. It's a bit of an educational thing. Um, so firstly, I'm gonna like whenever you see like a constant integral for some reason, there's just a constant the 2x. I'm just gonna get like I'm just gonna let I of x equals integral. So what? Let's write a bit. Yeah. So what's basically saying is I'm gonna let this integral be as a function of x kind of. So like for example, I of one, you may guess what that is. It'll be the integral to minus t squared cos of 2t dt. Okay. Obviously integral 0 to infinity. Um, but now there's like this the way this integral is hard is that there's so many like like tricks to what you gotta do, which we'll find out while we do this integral. I haven't even fully solved it. I'm doing a freestyle for this vid, but I hope there's a clean answer. We'll find out. And then yeah, let's get straight into it. So the way Feynman's trick works, you may think, well, what can we do here? Like we wrote I of x, can we integrate our parts? Unfortunately, parts wouldn't work, just because you have the square here, which just annoys it pretty much. It's very annoying. So we're actually gonna differentiate our integral. You may think, how do you even do that? Well, luckily I'm gonna write something and just explain what this means. Now you may think, what just happened here? I got the derivative somehow went inside. Because we're differentiating with respect to x, you can this is actually what this is legal, like you won't get stopped by police, whatever, if you do this in school, don't worry. You just differentiate like the part of the function that has the x term. So now this will equal minus t squared. So the derivative of cos is minus sine, but then we have to times by 2t outside because it's gonna be minus 2t sine 2xt. I'll write it in here. There we go. Now, there's something you might notice. Something very clean. There's a reason I didn't like let a equal 2x and then see, okay, let's solve I of a. Like, so instead of x, it's just a. Because then it all looks cleaner, right? You just got one little constant, 2x won't do anything. But the reason we left the 2 in there is, do you notice anything of this? This is the derivative of e power minus t squared. And then this is another clean function. So now by parts can work. Let's find out. So I'm going to use the DI method. So I want to integrate this function. I'm going to differentiate sine 2xt. And then our derivative of sine is cos, but then we have to times by 2x. 2x. Because 2x finger is just constant when you're doing chain rule, like because this is dt times of t. Before was times of x, that's why we times by 2t, okay? And then the integral of this is just e to the power minus t squared. So now this is equal to e to minus t squared. So and you may think what's going on here, this DI method. Basically you multiply across and you just do the limits. So if it was like I think it's definitely indefinite integral where you have no limits, then you just like the integral will literally be like these two functions times the integral of these two functions. Now they've got bounds, we have to put them in. And we take away, so The reason it's plus and minuses is like here, if this is a minus, this would mean minus e to the power minus t squared sine of 2xt. So you just follow like what the graph says, okay? And then now we times across, and we have a minus here, so it's going to be, that's why I put the minus here, okay? Because it'll be plus minus times. Infinity to 0, 2x. I'm going to take 2x on outside. And then I'm going to just erase all this. And now there's something very peculiar about this. Isn't this the function we're trying to solve? Who knows? And let's just first evaluate this. If you plug infinity in, 1 of e to the power minus infinity is like 0, so it's going to be 0. Take away. Now if you plug 0, sine 0 is also 0, so actually the whole thing vanishes. And we're left with negative 2x I of x. So we just found a relation. We got I dash of x, so x, I of x. And now you think, how do you even... Now this is the sick part. We basically got a differential equation. And luckily, we use a neat trick here, which hopefully you can spot it. If you don't, it's fine. I'm going to divide by ix on both sides. And now integrate both sides with respect to x. And I'll notice this is actually just the log of, so if I integrate both sides, this is just log of I of x, which equals 2, and the integral of negative 2x is going to be negative 2x squared and divided by 2, so squared plus c, where c is a constant, okay, and we have to find c. And then now if we just take e of both sides, we get I of x e to the power minus x squared plus c. And c is obviously on the power. So we got this relation. Now you may think, how do you find c? Well, what was I of x in the first place? I of x was our integral, right? And it works for any x. So to find the constant, we just have to basically pick a value for x. And if we know the integral, then we're good. Now, maybe the easiest one will be, what would I of 0 be? Because I of 0 equals integral from infinity to 0. Cos of 0 is 1, so it's just going to be left e to minus t squared dt. And now you may notice this is actually, so I'm going to tell you the Gaussian integral is basically infinity minus infinity squared dt square root pi. Now because this is an even function, it is an even function, right? Yeah, because if you plug like minus t into it, it's still minus t squared on the power. So this is the same as 2 dots integral infinity to 0 over 2. See what happened there? So this is actually root pi over 2. And now you may think, hold on, what's going on here? Like we literally got I of 0 root pi over 2. So now we're gonna plug 0 in. So root pi over 2 equals e to the power minus x squared plus c, and then obviously, sorry, yeah. See, some of this one is so many symbols, like it's a bit hard to type. And obviously x is 0, so now this is just going to be e to the c. And actually, we don't really need to, like, we have e to the power of c, because remember, I of x is equal to the power of x squared times e to the power of c, but what's e to the power of c? Root pi over 2. So it's actually, in fact, I of x is equal to square root pi over 2 e to the power minus x squared. And that is our answer for today. That's a clean answer, isn't it? So yeah, so a couple of things to talk about. So we use Feynman's trick. This is Feynman's trick. Used by parts. This is like a first order D. And yeah, and then we managed to get a very clean answer. Okay, I can't lie, that was way cleaner than expected. Because the thing is, I knew from the beginning, like if you plug 0, you do get like the Gaussian, but yeah, that was clean. I hope you guys agree. But yeah, I'm gonna leave it there. That's me for this video. I'm gonna be making videos daily. This is pretty much a channel for like a whole bunch of maths that you've never seen before, and I'll explain it clearly to you guys. So yeah, stay grinding. Peace.